Okay, so I'm assuming there are no questions then. In that case, we are going to start the last concept that we have, which is trigonometric graphs. So let's go through these concepts today then. Trigonometric graphs. Okay, so you need to be able to draw graphs of these functions as well. Not actually draw, sketch the graphs of sine x, cos x, and tan x. All right, so you need to be able to draw graphs of these functions. So let's try how. Let's see how we're going to be actually doing that. How we're going to be drawing the graphs of these three functions. We're going to start with sine first of all. Y equals sine of x. Let's see how the graph of this function looks like. Y equals sine x. Now remember how you used to draw graphs in O levels in the graphs of functions topic. You used to take some values of x, input some values of x in the function, get some corresponding values of y from that, and then you would just plot those values and join the points. We're going to be doing something similar here as well, right? We will be doing something similar here. We will just be inputting some values of x in this function, get some corresponding values of y, plot those values, and then just join those points. All right, so that's how we're going to start this first of all. Now, generally, when you will be asked to draw graphs of these functions, you will be given some kind of interval for x. So in this case, for instance, you might be given that x is supposed to be between 0 degrees and 360 degrees. That might be the interval that you're given. Now, in this case, how would you draw the graph? How would you sketch the graph? You would have two axes like this, x and y axes. On the horizontal axis, you are going to have values from 0 to 360 degrees because that's the interval that you have for x, from 0 degrees to 360 degrees. And then since you want a reasonable number of values to be able to understand the shape of the graph, you can divide this into multiple parts. You can say, let's divide it into half first of all. That gives you 180 here. Then divide it again into halves. That gives you 90 and 270. Now, since this is the first time that we're drawing this graph and we do not even know the shape of the graph yet, we don't know how the shape of the graph looks like, what we can do is we can take some more values in the middle as well. So since it's the first time we're drawing it, let's take some more values. Let's say 45 degrees as well. That will help us understand the shape of the graph better if we take more values. So we have 45 degrees here, and we have 135 degrees here, and we have 225 here, and then 315 here. Now, in your exam, you will not get graph paper to draw this. You will have to do this on a blank paper. Okay, you'll have blank space on the paper. You will have to draw x and y axis yourself, mark all of these points yourself. Now, when you're doing this, even though it's a sketch, which means it does not have to be very, very accurate, the intervals should still be reasonably equal. Okay, don't do something like this that you have, for instance, 90 here, and then you have 180 here. That does not make sense. The intervals should look fairly equal. Okay, so what I've done is I have written down all of these values on the x-axis from 0 to 360 at an interval of 360 degrees. Now what we can do is we can input all of these values in this function one by one and get the corresponding values for y and plot them. But there's a quicker way of doing this. There's a quicker way of doing this, and that is using a function on your calculator, which is called the table function. Okay, you have this in pretty much every calculator. Table function. we will be using that table function to draw, to basically get a table of values for X and Y. Okay. Now, how is that going to happen? Let me draw a table here first of all, and then we're going to fill that table using that table function. Now, for plotting these values, we are saying we want a table of values for X and Y. So we have X here and we have Y here. And then we can say the values of X are 0, 45. Let me first write 0, then 180 somewhere here, and then 360 here. And I can break it down into parts: 90, 270, 45, 135, 225, and 315. So I have all of these values in degrees. Okay, I want to write down the corresponding values of Y for all of these values. Okay, now how can I do that? One way is to put all of these values one by one in this function, making sure the calculator is in degrees mode. The other way and more efficient way is using the table function on your calculator. So what you're going to do now is, on your calculator, go to setup. No, not setup. Go to menu. Now, if you have ClassWiz, you have to go to menu for that. If you have another calculator, I think you'll have to go to mode. And you will find the table function somewhere. So I have this version right now. This version, ClassWiz. On this version, if you open menu, at number 9, you have table. So you'll open that function. You'll basically press on that 9 button, and you'll have that table mode active. On other calculators, you'll most likely have to go to mode, and you'll find the table option there as well. Okay. What you have to do now is you have to make sure, first of all, your calculator is in degrees mode, because the values of X here are all in degrees. And on your calculator, you're now going to write f of X. So you'll already see f of X there. Once you're in table mode, you will see f of X written there. And you say f of X equals sine of X. This is what you're going to input there. Sine of X, right? That's the function. How do you write X there? Look at this button on your calculator, the bracket close button, right? It's above the delete button mostly. Above that button, you have X written in red. So you'll have to press alpha to access X. So write sine X on your calculator. Okay. Once you're done with that, press the equal button. If you have ClassWiz, again, if you have this calculator, the calculator is going to ask you for G of X. Otherwise, the next window will show you start. Now, G of X is basically used to get a table for two functions at the same time. Now, for now, we are just dealing with one function, that's sine X. So we just skip G of X. How would you do that? If you have G of X shown on your calculator, just press the equal button again. It will skip G of X. Okay. And the next screen that you will then see would be that has start written there. Now, start means where do the values of X start? They start from 0. So you write 0 there and press equal to button. Then the cursor is going to move to end. You have to end at 360. So you write 360 there and press the equal button again. And then step. Step means what is the interval that you need. So start is 0, end is 360. At what interval do you need your values? You need the values at 45-degree intervals. So at step, you write 45. Press the equal button again. When you do that, you will get a whole table there, which will contain all of these values for X and Y. So at 0, the Y value is 0. At 45, it's 0.707 something. But since we are just sketching, one decimal place is going to be enough. We say this is 0.7. At 90, it's 1. Then you have 0.7, then 0 again, then minus 0.7, then minus 1, then minus 0.7, and 0. These are all the values that you get on your calculator, right? Now you do not even have to draw this table anymore because you're not doing it one by one. You have the whole table in front of you on your calculator. The examiner will not ask you to draw this table generally. They will just ask you to sketch the graph. So what you can do is you can just make the table on your calculator and just plot the values directly by looking at your calculator screen, right? So you don't have to write these values here. That's not necessary. Okay, so now let's plot these values. What's the lowest value? What's the smallest y value? It's -1. What's the largest y value? 1. And we know that's exactly how it should be as well, because sine x is between -1 and 1. We've discussed that before. The smallest possible value of sine is -1, and the largest possible value is +1. So on the y-axis, we have to go from -1 to +1. Okay. Let's just plot those values now. At 0, you have 0. At 45, you have 0.7. Again, you have to just mark that roughly. It does not have to be very accurate. Okay, so you have 1 here, and you have -1 here. At 0, the value is 0. At 45 degrees, it's 0.7. So roughly it's going to be here. At 90, you have 1, and then 0.7, and then 0, and then -0.7, -1, -0.7, and 0. And looking at these points, now you get an idea about the shape of the graph. The shape of the graph is going to look like this. It's going to go like this, maximum 0.1, and it comes back here, and then it goes down below the x-axis, and then it comes up like this. This is what the graph of sine x looks like. This is y equals sine of x. All right, this is y equals sine of x. This is how the graph looks like. That's drawn. Now, this is the standard sine graph shape. A wave like this. Beyond 0 and 360, it's going to continue this shape. It's going to keep going on like this. Right? So it keeps going on the right side as well as on the left side like this. Okay. Now this is in degrees. You could also draw this in radians. Your x-axis could be in radians. That's possible. In that case, your values would be 0, and then pi over 4, and then pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Right? These are going to be the values in radians, and the graph shape is going to look exactly like this. You can do that as well. No, Adam, you don't have to make the table. You don't have to make the table. You can sketch the graph directly. So you can just make the table on your calculator and plot values directly from the calculator. Don't have to draw this table. Generally, it's just like a 2-mark question. So writing down values in this table is going to be a lot of work. So you won't be doing that. You will just be plotting values directly from your calculator. Okay. So that's how the sine graph looks like. Any problem with this? So you can say the minimum point of this graph is -1, the maximum point of this graph is +1. And from 0 to 360, this graph is completing one full cycle. From 0 to 360, one full cycle is completed, and then this graph just keeps repeating itself on the right side and also on the left side. And the reason for that is 0 to 360, one full circle is completed. And then since you're just going around in circles, the angles are the same as before. Their sine, cos, tan values are the same. So it just keeps repeating like this because you're just going around in circles like that. Okay, so that's the graph of y equals sine x. Any problem with this? Any problem with this, anyone? No? Now, what you need to remember from this is the shape of the graph. Okay, the rest of it you can just figure out using a calculator. This is just y equals sine x. A lot of times you will be asked to draw a graph. So for instance, y equals 2 sine x plus 1. So you have something multiplying outside. You could have something added or subtracted outside. You could have something like this as well, y equals sine of x plus 2, or maybe x plus 30. And you could have y equals sine of 2x minus 60. So functions like these, you might have to draw graphs of these functions. What you're going to do is you're just going to remember the shape of the graph. It's going to look something like this. Roughly, it's going to look like this. Or it could be the other way around, sometimes flipped. It could be like this, right? But it's going to be something similar to this. So once you remember that this is the shape of the graph, you can just plot those values on your calculator. You can use the table function to find some values on the calculator, plot them, and just join those points like this, and that will give you the graph. Okay, all right, let's move on. This was y equals sine x. Now think about y equals cos x. Do exactly the same thing on that as well. Make a table function, and instead of sine here, use cos. Okay, so everything is going to be the same as before. I'm just going to copy all of this. Okay, let's think about cos of x now. Okay, so what about cos? Let me just change these values now. Okay, so now we have y equals cos of x. Use the table function on your calculator again. You will get these values for cos as well. So cos of 0 is going to give you 1, and then you would have 0.7, and then 0, and then minus 0.7, then minus 1, minus 0.7, and then 0, and then 0.7 again, and then 1. These are the values that you're going to get from the cos graph. Okay, again, use the table function and draw a table like this on your calculator. You don't necessarily have to copy that. Okay, just plot these values on this graph. Now at 0 you've got 1, and at 45 degrees you have 0.7, and then you have 0 at 90, 135 and minus 0.7, 180 and minus 1, and then 0 minus 0.7, and then 0, and then 0.7, and then finally you have 1. What is the graph going to look like now? It will be this. This is the graph of y equals cos of x. Okay. This is y equals cos of x for 0 to 360. This is how the graph looks like. Okay, and again, just like sine, beyond this interval, the graph is just going to keep repeating itself. Okay, it'll be like this and this and so on. Similarly on the right side as well. So you see, it's actually the same shape as before. It's the same shape as the sine graph. It's exactly the same shape. It's just that the sine graph was starting from 0 and then going from 0 to 1, then back to 0, and then minus, and then back to 0. Cos graph, on the other hand, is starting from 1 and going from 1 to 0, and then minus 1, and then 0, and then 1. So they're starting at different points, but the shape of the two graphs is exactly the same. In fact, if you were to shift this cos graph on towards right by 90 degrees, you would get the sine graph. So if you bring this point here, that gives you the sine graph, right? So they're exactly the same shape, just with different starting points. Is this okay? This is the cos graph. All right. Again, you may have to draw different variations of this graph. You could have something multiplying outside, adding or subtracting, or things like that. We will learn how to deal with all of those different transformations. But this is how it looks like. Okay. All right. Now, this is the cos graph. Again, you have to remember the shape of the graph. This is the rough shape of the graph. It goes like this. Sorry. For one complete cycle, it looks like this. Okay, and sine graph looked like this for one complete cycle. Okay, let's have a look at the next one now. Let's look at tan. Once you remember the shape, you will understand that you mostly just need to take values at 90-degree intervals, and that they are going to be enough. Because once you remember the shape, now you know how the curve is going to look like. So even if you have some points, even if you don't have all of these points, and you just have, for instance, these points, 0 and then 90 and then 180 and then 270 and then finally 360, these points even are going to be enough to sketch the graph once you remember the shape. If you don't remember the shape, then you will need to take more points. Otherwise, these are going to be enough. Okay, similarly here as well for sine, these points are generally going to be enough. Okay. And these points are important to show on the graph as well. These points have to be reasonably accurate. Your graph has to pass through these points. Okay, so it should be clearly visible on your graph. All right, now the next one is tan x. Now let's make the tan graph, the tan x table on your calculator first of all. So now you want y equals tan of x. What would that look like? Okay, so now we have y-axis here again, and we have x-axis here. We want values from 0 degrees to 360 degrees or 0 to 2 pi. 0 to 360. Let's break it in the middle. That's 180. Then this is going to be 90. And this will be 100, no, 270. Then you have points in the middle as well. This is 45, 135, 225, and 315. Okay, so you again draw a table like this on your calculator. At 0, the table is going to give you 0. At 45, you will get 1. What about 90? What are you getting at 90? Have you tried this on your calculator? You're getting an error, right? Yeah, so your calculator should give you an error at 90. The reason for that is tan of 90 is undefined. Tan 90 does not have a value. Okay, so this is undefined. Now, one way to understand that is using that tan identity. Remember, tan theta is equal to sine theta over cos theta. So tan 90 would be sine 90 over cos 90. What is sine 90? Sine 90 is 1. What is cos 90? Cos 90 is 0. 1 over 0, that is undefined. So we don't have a value for this. Okay? So tan of 90 is giving an error. What that means is the function is undefined when x equals 90. Okay, what about 135? When you input x equals 135, that gives you -1, then think again. Yeah, so at 135 you have -1, at 180 you would have 0, and then 225 would be 1, and then at 270 you would again have undefined, and then at 130, then 315 will be -1, and then 360 would be 0. These are the values that you should be getting on your calculator, right? Let's plot these values. Let's plot these values. At 0, we have 0. Okay. Then let me just write 1 here and -1 here. At 0, we've got 0. At 45 degrees, we've got 1. At 90, it's undefined. Okay, let's skip that for now. At 90, it's undefined. At 135, it's -1. At 180, it's 0. And at 225, it's 1. At 315, it's -1. And then at 360, it's 0 again. These are the points that we have. Now, remember, the graph is undefined at 90 and at 225. Undefined means the function does not have any value when x equals 90 and when x equals 270. So x equal 270 cannot give you any value for y, which means the graph is not going to exist there. The graph is not going to exist when x equals 90 or when x equals 270. The graph is not going to exist at these values of x, which means there's going to be a break in the graph, because the graph cannot now cross x equals 90. So what you do in tan graphs generally is that you make a vertical line like this at 90. You make a vertical line like this. And similarly, you make a vertical line at 270. And you generally make it dotted or dashed like this. The tan graph cannot pass through this line. Okay? It cannot pass through this line because there's no value of tan at 90 and 270. So the graph is going to be broken. It's going to be in multiple parts. So we have one part on the left side. You have 1 point here, 0, another point, 45 and 1. And then you have some points in the middle. You have this point and this point and this point. You have this point here and this point here. Right? How is the graph going to look like now? Now, it's not very clear just by looking at these points that we have at this point, because 2 points could be joined using a straight line, for instance, as well. How do we know how the shape is going to look like and what happens after this point? How do you understand that? Now, tan 90 is undefined. Tan 90 is undefined. But what you can do is you can say, let's try a value that's slightly less than 90 instead. So take a value slightly less than 90. For example, try tan of 89. What does that give you? Tan of 89. Tan 89 gives me 57. 57 point something. Try 89.9. 573. Try 89.99. 5,700. So basically what's happening is, as the value of x gets closer and closer to 90, the y value becomes very large. So even at 89, it's 57. That's a pretty large value considering that this is 1. So as you get closer to 90 degrees, the value of tan increases. So the graph is going to look like this. It's going to go here, and then it's going to be going upwards like this. It's going to keep going up, but never actually touch this line. Okay, it will never touch the line x equals 90. Okay. Any problem with this? Any questions on this, anyone?
No, sir.
No? So this is what the graph looks like before x equals 90. Now what happens after that? If you try a value right after x equals 90, for example, try tan of 91. So you want to see what happens on the other side of 90, on the right side of 90. Try tan of 91. That would give you minus 57. That means on the right side now, the value is going towards the negative side. So it's actually going towards negative infinity. So the graph on this side is going to look like this. From 180, you will have a line, you have a curve like this, so the graph is going in this direction. And again, try another value close to 270, because again, tan is undefined when x equals 270. You can try 269, for instance. Tan of 269 is going to give you 57, and 57 again, that's a large value, large positive value. So on this side, the graph goes like this. And then try another value to the right of 270. That will be a large negative value. So on this side, the graph looks like this. Okay. These lines that we have drawn in the middle, these lines are known as asymptotes. These lines are called asymptotes. The graph does not touch these lines. The graph keeps going closer and closer to these lines, as in the distance between the graph and these lines is going to get smaller and smaller, but the graph is never actually going to touch the line. Okay. So on one side, it's going towards positive infinity. On the other side, it's going towards negative infinity, then positive infinity, negative infinity. This is the graph of tan x. Okay. this is how the graph of tan x looks like. It's in different parts like this. It's in multiple parts. Okay. If you were to extend this graph on the sides now, the graph keeps repeating like this. You have an asymptote at minus 90 as well here on the left side. Similarly, it's going to extend like this on the right side as well. So this is also a cyclic graph, right? What's one complete cycle in this graph? You can consider this one complete cycle, right? This is the shape that is basically repeating. Okay, this is the shape that keeps repeating itself. Make sense? Is my voice breaking for anyone? Or is it okay?
No,
sir.
no, sir. No, sir.
No? Okay, my other device is not updating for some reason. Let's check.
Sir, do we say that one cycle is 0 to 180?
You can say that. The interval is 180, right? The total interval is 180. Now, you could start from anywhere, it doesn't matter. This is the shape that's repeating, right? So the gap between the interval, the width of the interval, the 180. You can say one cycle is 0 to 180. You could say one cycle is 90 to 270 or 180 to 360. The interval is 180 degrees, right?
Sir,
Yeah.
sir, like at 270 it doesn't give any value, so shouldn't it be between 180?
Between 180. So you're saying less than 180, right?
Yes, yes.
Yeah, so that's a good point because at 90 it's not giving us any value, and 270 it's also not giving us any value. So you're saying we should not be saying it's exactly 180.
Yes, sir.
But think about it. At 90, it does not give us any value, right? But can it give us a value at 90.000000 and then infinity many zeros and then maybe a 1? And similarly, at 270, yes, it does not give us any value, but doesn't it give us a value at 269.999999999 and then infinitely many nines like this? So yes, exactly 270 is not possible. Exactly 90 is not possible. But if you find the difference of these two values, that's pretty much equal to 180 as well. Make sense?
Yes, sir.
Yeah. So we consider it 180. Effectively, it's 180, right? So yeah, so you can say 179.99999 and then infinity many nines. Now you can't write those infinity many nines like that. So you just say it's 180 instead. Okay. All right. Now that's the graph of tan x. Now there are some terminologies that are used with respect to these graphs that you need to be aware of. First of all, we've got something that we call period of a graph. How is period defined? Period is basically the cycle or the interval in which the graph completes one full cycle. One full cycle. It's the interval in which the graph completes one full cycle. What's one full cycle? One cycle is the shape that is repeating, itself. So for example, for tan, this yellow shaded part is the one that is repeating. For cos, this shaded part is the one that's repeating. And similarly for sine, this is the part that's repeating. So period is the interval in which one full cycle gets completed. So if you think about sine now, what is the interval in which one cycle is completing? It's 360 degrees. In radians, it would be 2 pi radians. For cos, the period is 360 degrees. In radians, that would be 2 pi radians. And for tan, one full cycle is completing in 180 degrees, right? And in radians, that would be pi. So the period of sine and cos functions is 360 degrees, and the period of tan function is 180 degrees. In radians, that would be 2 pi and pi. Okay. All right. So that's the idea of period. Then there's another thing that's defined that we call baseline of the graph. What is the baseline? It's the horizontal line exactly in the middle of the highest and lowest points of the graph of the maximum and minimum points on the graph, about which the graph moves or oscillates up and down. That's the baseline. Now let's try to understand what that is using, so let me just leave it here for a moment. It's the horizontal line exactly in the middle of the maximum and minimum points on the graph, about which the graph oscillates up and down. So for example, for sine graph, what's the highest point? Highest point is at 1. What's the lowest point? -1. Exactly in the middle, you have this horizontal line, which in this case is the x-axis. This is the line about which the graph is moving up and down. Okay. Similarly, for cos function, what's the highest point? The highest point is 1 and the lowest point is -1. What's the line exactly in the middle? That's this horizontal line. This is the line about which the graph is moving up and down. It's x-axis in this case as well. And for tan as well, the baseline is the x-axis, about which the graph moves up and down. It's kind of exactly in the middle. Okay. Now in simple sine, cos, and tan graphs, baseline is the x-axis. But if you had some transformation of these functions, for example, sine x plus something or minus something, cos x plus something or minus something, tan x plus something or minus something, then the baseline would also shift. And that's something that we will talk about shortly as well. But that's the idea of baseline. Okay. By the way, is my voice clear to everyone? Is it matching with what you're seeing on your screen as well? Because on my other device, it's really weird right now because it's way behind what I'm doing on my other screen. Is it fine for you guys?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, maybe I can try. Okay, thank you. Something wrong with my other device then. Okay, anyway. So we have the baseline, and then the final thing that we want to know about is amplitude. Amplitude is defined as the maximum displacement, the maximum vertical displacement of the graph from baseline. So if you look at sine graph, for instance, the baseline we said was the x-axis. What's the maximum displacement from the x-axis? 1 unit up and 1 unit down. So the amplitude for sine is 1. Similarly, for cos as well, the maximum displacement is 1 unit up, 1 unit down. Again, amplitude for this is also 1. What about tan? For tan, it's undefined. There's no maximum vertical displacement for tan because it's just infinity. You could either say it's infinity or you could say it's undefined. Okay. So now for these three graphs that we've drawn here, we have these two things defined. We have the sine function, and we have the cos function, and we have the tan function. And what we have defined for these graphs is the period of the graph. That was one thing. And also amplitude of the graph. So for the sine graph, the period is 360 degrees. In radians, that would be 2 pi. In cos as well, it's 360 degrees or 2 pi. And in tan as well, it's 180 degrees and pi. Amplitude for sine is 1, amplitude for cos is 1, and amplitude for tan is infinity. Or you can say undefined. Both of them are acceptable. Okay, so this is what you need to know about the basic sine, cos, and tan functions. Any problem with this, anyone?
No, sir.
No?
No, sir.
Okay, so now we need to understand, now we want to understand what happens if you do not have a simple sine or cos or tan function, but you have some transformation of that, something multiplying with that, something being added to that, something being subtracted from that, and so on. What happens in that case? For example, if you had something like this, so if we write down the most complicated case you could possibly get y equals minus 2 sine of minus 4x plus 30 degrees minus 7. What about this graph? What is this going to look like? What is really happening to this graph? What transformations are happening? That's what you want to understand right now. Is it okay if I go on for like 15 more minutes? 15 more minutes? Is that okay? Or should we do it in the next class? Can we discuss transformations of these graphs?
Yes,
I
sir.
hope no one is very sleepy right now. Okay, let's actually go ahead and at least do the vertical transformations. Horizontal, we'll see if they're going to take more time. We might leave them for next class. let's start with vertical transformations at least. There are two types of transformations that can happen. One is vertical transformation, the other is horizontal transformation. Vertical transformation means the graph moves vertically up or down. Horizontal transformations mean that the graph moves horizontally left or right. Okay. Now, we haven't done functions yet. We will be talking about these transformations in functions later as well, as in how these transformations work. But let's understand it using these trigonometric functions right now. And this understanding would later help us in functions as well then. Vertical transformations. I'm not going to be using the proper transformation language here as such, but we will at least understand the concept as in how the graph moves because of these transformations. For instance, if I have a function, let me actually show this on Desmos directly first. Okay, so let's say I have a graph like this. If I have y equals sine of x, this is what the graph looks like, and the values here are a bit weird right now. Let me just change the units. Y equals sine of x. So we have this graph. Let me convert the unit to degrees, so it's easier to understand. Remove minor cut lines. Degrees. Let's go from minus 360 to 720. Okay, so this is what the sine graph looks like, right? So you can say it's a wave function like this. It just keeps repeating itself. All right, now if I were to draw this function instead, y equals sine of x, and have a plus 2 outside, what do you think is going to happen to this function?
It's gonna start on 2.
It's going to start at 2. So basically, every single point on the graph is going to move up by 2 units. Every single point in the graph will move up by 2 units. Why? Because we are adding 2 to the y value. Earlier, the y value was sine x. Now we are adding 2 to every value earlier. So every point is going to move 2 units up. So the point at 0 will go to 2 here. The point at 1 will go to 3. The point at 0 here would go to 2. The point at -1 is going to go to +1. So every point is going to go 2 units up. So if I were to draw the graph of this function, y equals sine x plus 2, this is what it would look like. Every point would go 2 units up like this. This is vertical translation. The graph is moving up by 2 units. Okay, the graph is moving up by 2 units. It's shifting up by 2 units.
Sir,
Yeah.
sir, then the midpoint will also be 2. or the starting point? We will say it's starting point or midpoint.
The baseline, if you mean that, the baseline would be y equals 2. This would be the baseline. This is the baseline. Is that what you're talking about? So yeah, the graph is now going to be moving about this line, about the line y equals 2. That's the baseline. So it starts from 2, goes up to 3, then comes back to -1, then keeps oscillating like this. If instead of +2, we did minus something, let's say we did -4, now the graph moves 4 units down. So if we add or subtract something outside the function, the graph moves up or down like this. This is called vertical translation. The graph is moving up or down. It's a translation. The baseline is shifting. The baseline was earlier 0 in the original graph. The baseline is 0. So we can think of that as +0. So whatever is the number outside, that's the baseline, right? So initially the baseline was at y equals 0, the x-axis. If we have any number outside, then the baseline basically shifts to that number. In this case, for instance, the baseline is y equals -4. This is the baseline, -4. Okay, so the number outside represents where the baseline of the graph is. Okay, so that's what happens when we add or subtract something to a function. Then another transformation could be that we multiply by something. So we have sine x. What if we multiply sine x by some number? For instance, if we multiply sine x by 2, what happens in this case? Every single y value is going to get multiplied by 2. Let's think what is going to happen in this case. Since every single y value is going to get multiplied by 2, what happens to this point? The point that was at 0. 0 multiplied by 0 is still 0, right? So that point remains there. What about this point? The point at y equals 1 earlier. When you multiply this by 2, this is going to go to 2. So the point at 1 moves to 2. The point at 0 remains at 0. The point at -1 goes to -2. And the point at 3, 6, and the point at 0 remains at 0. The graph is going to look like this. Okay, it will be something like this. So you can see what's happening. The graph is stretched. The graph is vertically stretched. And if you were to think of amplitude of this graph, the amplitude of the graph becomes twice as compared to what it was before. So it was 1 before, now it's 2. So the number outside here represents the amplitude of the graph. So when you multiply by 2, multiply a sine function or a cos function by 2, 2 becomes the amplitude. 2 is the amplitude of that graph. Is that all right?
Yes, sir.
Okay. And then finally, if you did something like this, that you had, so this is what 2 sine x looks like, right? The amplitude becomes twice as compared to what it was before. If it was 3 sine x, for instance, the amplitude becomes 3, right? Now, instead of this, if I had, for instance, minus sine x, what happens in this case? Every y value gets multiplied by negative. So whatever value was positive earlier, for instance, the value at 1, that's going to go to -1. The value at -1 is going to go to 1. The value at 0 will remain as it is because 0 into -1 is still 0. The graph is going to flip like this. How do you describe this transformation? This is the reflection. It's a reflection in the x-axis. The graph gets reflected in the x-axis. It's a vertical reflection in the sense that the graph is moving vertically. The points above the graph, above the x-axis, are moving below the x-axis, and the points below the x-axis are moving above the x-axis. So it's a vertical reflection. Line of reflection is x-axis. Okay. So that's what happens when we multiply by a negative sign like this. Okay. So there are three transformations that we discussed. These are vertical transformations. In vertical transformations, only the y coordinates change. The graph moves vertically, up or down. Now, let's try to summarize those three transformations that we looked at there. You could have a function like this, y equals sine of x. The possible transformations are that you could have some number multiplying outside, or you could have a minus sign multiplying outside, or you could have something being added or subtracted outside the function. So you could have this number multiplying, you could have a minus sign multiplying, or you could have some number added or subtracted. Now, all of this is happening outside the function. Horizontal transformation would be if you have something inside, for example, sine of 2x, that will be horizontal. If you have sine of x plus 30, if you're doing something to x, that is horizontal. That's not what we're doing. We're doing something to the whole function. Sine of x was the whole function. We're doing something outside that. Okay. Now, the first transformation that we have here is multiplying by the negative sign. What does that mean? That basically means it's a reflection. We call this vertical reflection. You can say this is reflection in x-axis. Reflection in axis means that the line of reflection is x-axis. We have to write it like that. It's a reflection, vertical reflection, of course. The line of reflection is x-axis. Why do we call it vertical? The movement of graph is vertical. If x-axis is the line of reflection, the point above the x-axis moves below, the point below the x-axis moves up. So the movement is vertical. That's why we call it vertical. Line of reflection is the x-axis. Okay. What happens to this is stretch. Okay, this is stretch. The graph is vertically stretched. Okay. And as we will find out later, I'm just going to write it down here for now, but we'll understand this later. Scale factor of the stretch is A. Okay, the number that we're multiplying with. But the more important thing for now is that the amplitude of the graph becomes A. Whatever is the number multiplying outside, that becomes the amplitude of the graph. Okay. Now, scale factor thing we will understand in transformations later, function transformations. For now, this is more important. Amplitude equals A. And then finally, we could have something added or subtracted outside, like we have plus minus B here. This is translation. Now, if you were to write down a translation vector for this, it would look like this. So when you have plus B, that means the graph is moving B units up. When you have minus B, that means the graph is moving B units down. And normally, as we'll find out later, to describe a translation, we usually use a vector. You know about that, about vectors, translation vectors from O levels as well. The vector for this would look like this, 0, because there's no horizontal transformation. Y component of that vector would be B. Plus B, if you have plus B here, you have plus B in the vector. If you have minus B here, you have minus B in the vector. In the terms of a trigonometric function, what happens is your baseline shifts. Initially, your baseline was y equal to 0. Now your baseline would shift to this y equals plus minus b. So whatever that number is, for example, if you have y equals sine of x plus 3, the baseline is going to be at y equals 3. Okay, so these are the vertical transformations that are possible in trigonometric functions. For sine and cos in particular. For tan, would not say anything about the amplitude, right? It's just going to be a stretch still, but we would not be mentioning amplitude there, of course, because the amplitude of tan does not exist. But for sine and cos, this is how we describe these transformations. Okay. Now, in the next class, we will learn how to do horizontal transformations as well. But now you should be able to do the assigned questions from the worksheet. You should be able to attempt them at least. So I expect you to attempt those questions from the worksheet. We will be discussing those questions in the next class, inshallah. We'll start our next class by understanding horizontal transformations of these graphs first. And then we will be doing those questions that I have assigned from the worksheet on trigonometric graphs. So I expect you to attempt those questions. Please make sure that you do that. And hopefully on Thursday, we can start our next topic then, inshallah, which is most likely going to be coordinate geometry. Any questions, anyone? Any problems?
No, sir.
No? All right, so then tomorrow we will learn how to do horizontal transformations and also do some practice questions in this. You can attempt some of those questions already now. So the last row of the assigned questions, I suppose, you can start working on that. All right, I'll see you again tomorrow then. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.